Hello everyone, welcome back to my channel. So in this video, we're going to talk about the most important program which would be asked in, for junior level as well as, till 4 years of experience. They will ask you how to test the programming skills, that is prime number. Okay, so most of them will get confused how to write a program for a prime number. It is pretty much easy if you go over this video, right? Okay, so first most important thing is we need to know what is a prime number. If you don't know what is a prime number, then it is really difficult for you to write a program for the same, right? So what is a prime number, right? So that is the first thing, it should run in your mind, right? So a prime number is said to be, a number is said to be a prime number only if it is divisible by one and itself. Okay, if you consider any number, if you consider 3, it is divisible by 1 and 3. If you consider 10, it is divisible by 1 as well as 2 as well as 5 and then followed by 10, right? So which means 10 is not a prime number. Okay, a prime number is said to be, a number is said to be a prime number only if it has it is divisible by 1 and itself, then we call it as a prime number. Obviously, that is what we call it as factors as well, right? A number should have two factors, that is 1 and itself, which means a factor is, if you consider any number, okay, let us assume 5 or maybe 6. Okay, so if you consider 6, what are all the numbers which will divide 6 from 1 to 6? We need to start from, as I said, like here the statement mentions that it should start from 1 and itself, which means it should start from 1 and itself till 6, right? So after dividing, whichever number leaves remainder 0, then we call it as, it's a factor for that number. Okay, so 1 is neither a prime number nor a composite number. Okay, 1 is neither a prime number nor a composite number. Don't get confused. So few prime numbers are as below. It is 2, 3, 5, 7, 11, 13, 17, 19, and so on. If you consider any number apart from this, the logic has to give us it's not a prime number. If you consider any number between whichever it is showing here, we need to display as it's a prime number, right? So that's what the code, that's how we need to write a logic for the same. Okay, let us solve this problem mathematically, and then before we start, we say that, how can we say that number is exactly divisible or not, right? So as I said, like, if you have any number which is divisible and leaves the remainder 0, right? So that is exactly divisible, and also that is a factor, that number is a factor for the number which we have taken, which means, as I said, like, as an example, if you consider 6, right? For 6, 1 after dividing, it will leave a remainder 0, and if you consider 2, 2 divided 6 divided by 2, it leaves a remainder 0, which means 2 is also a factor. If you consider 3, 6 divided by 3, which means it leaves a remainder 0. We all know that the operator which will be used to find the remainder is mod operator. It's not actually divisible, it is a mod operator we need to use, right? When you divide, when I say divide, it's programmatical in program. In terms of mathematical, is dividing. When you divide, you give 0, then we consider it as a fact, right? How it can be done, and then probably based on that, we will understand the logic for the same, right? Let us consider number 5, and we need to find the factors for 5. Okay, so factors for 5, let us start from 1, because we know that it has to start from 1 and itself. We need to find 1 itself, right? So 5 first starts with 1. Okay, So 1 after dividing, the remainder is 0, which means 1 is a factor. If you consider 2, so which means after you divide, it leaves remainder. 2 to 4, remainder is 1, which is it's not a factor. And then if you consider 3, it gives a remainder 2, which means it is also not a factor. It's not exactly divisible, dividing 5 with 3. And then if you consider 4, which means it leaves a remainder 1, it is also not a factor, right? And if you consider 5, it will give you remainder as 0, which means it's a factor. So if you see this clearly, it has two factors. One is 1 and itself. It can have multiple factors as well. In that case, if the factors are equal to 2, then only we can say that the number is a prime number. If it is having more than 2 factors, then it is not a prime number, right? Hope this clears, right? So where it has started, it started from 1 and it ended at 5. The number remains same. However, this number is getting incremented every time. Every time this number has to do the mod operation with 5 mod 1, and then this 5 mod 2, 5 mod 3, 5 mod 4, and then 5 mod 5. Okay, so it has to do for all the numbers and find the factors. If anywhere, if after coming out of this, after finding all the numbers till it reaches the number, after coming out, if it has factors only 2, then we consider that as a prime number. If not, no, it's not a prime number, right? So let us consider one more example. Let's take 6, consider 6, and we'll see 6, 1 is a factor. Obviously, 1 is a factor for all the numbers, right? And if you consider 2, yes, 2 again, 6 divided by 2, 6 modulus 2, if you consider mod operator in programmatical way, 6 mod 2, which means it leaves a remainder 0, it's a factor. Okay, so 3 again, it's a factor because 3 to 6, right? 4, it's not a factor, it leaves a remainder 2. And 5, it's not a factor because it leaves a remainder 1. And obviously 6, it's again divisible and then it leaves a remainder 0, which means it's a factor. So if you see this clearly, 1, 2, 3, 4 factors. So the rule says that it should have exactly 2 factors. If not, it's not a prime number. So 6 is not a prime number, right? So let us write a pseudocode for the same, where it has started and where it has ended. So it has started from 1, it ended at 6. Either way, you can start from 6 to 1 as well. So it's up to us to write a logic. There is no hard and fast rule for writing a logic. As long as you know the concept and you know what you are writing, then probably where you have to start, where you have to end. So that is up to us, right? But obviously it has to be starting from 1 till it reaches the number, right? So every time what we need to do, so starts with 1 and end at number, and check whether if it is divisible or not. What is the statement that which we need to use it here for checking it is divisible or not? That is mod operator, right? So number mod 2 mod the iteration number equals to 0, then we need to increase. If yes, add factor plus 1, which means we assume that there is a factor variable. So initially the factor value is 0, and then every time if you find any number which is divisible, which is divisible and leaves a remainder 0, then we're going to add factor 1 to it, right? So if after coming out of this iteration, if factor equals to 2, then it is a prime number, else it's not a prime number, right? So the logic is same. So we have number equals to 5, where we need to find number 5 is a prime number or not, and factor equals to 0. So iterate from 1 to 5. That is 5 is number. So for integer counter equals to, we should not start with 0 because we cannot divide with 0. So that's why we cannot start with 0. It should start from 1. So in case if we think that as we said, like it has to iterate 5 times because 5 number equals to 5, right? It has to iterate 5 times. It should always starts from 1. Okay, it's not like should start from 0, right? So I equals to integer counter equals to 1, counter less than or equals to number, counter plus plus, you go inside, and then we know that the operator which leaves a reminder after integer division is mod operator. So we need to use number mod counter is equals to 0. If it is equals to 0, means we're gonna add factor plus plus. Nothing else in the loop, because after coming out of this loop, we need to find if factor equals to 2, then we're gonna say it is a prime number. If not, it's not a prime number. So most of them will get confused while writing the logic. They'll write like inside this if state, inside this for loop, after if this number mod counter equals to 0, it's a factor plus plus, or they'll write like a system.out.println number is prime number, else number is not a prime number. So that is not the correct way of writing it. Okay. So what we are finding inside this for loop is finding whether it has how many factors that it has. Okay. So that is what we're going to find it inside this for loop. Okay. So don't get confused where we need to write this if else statement. It has to be outside of the for loop, because if you write it inside, every time if it is not dividing, then it will print it every time. So we should not be getting that, right? So in that case, we should not be writing it inside for loop. Okay. So let us go back and write a logic for the same. Before writing logic, let me write one. Let me go back to say one more thing. Right. So I'm keeping this slide for now to explain to write the program in better way. So let us go back and write the logic for the same. So I'm gonna write a new class here. This is prime number, public static void main, and then we know that integer factor equals to 0. Let us assume I'm finding a number. Assume that I wanted to find 19 is a prime number or not. Okay. So for integer I equals to 1, I less than or equals to number I plus plus, go inside if number mod I equals to 0, then factor plus plus. Nothing else in the for loop, but still we can either do this way. Okay. So after coming out of this loop, if factor equals to 2, then I'm gonna say that number 19, that is say prime number. Okay. Yes. Number is not a prime number. Okay, let me run this piece of code and see what would be the output. Number 19 is a prime number, right? So let us see how many times this loop will iterate. Okay, so it starts from 1 and it ends up at 19, which means it has to execute 19 times to get the factors, right? So let us simplify this logic. Okay, so this is one of the logic which most of them will write. Let us simplify this logic. Okay, so let us see this slide carefully. Okay, so let us we say that a prime number is which is divisible by 1 and itself. Let us eliminate 1 and itself, which means this loop has to start from 2. Okay, and end at I less than number. Okay, so in between, if you consider any number which is divisible, which means which leaves a remainder 0, then obviously, apart from this 1 and 6, if any number which is divisible, then obviously that is not a prime number. We no need to go further as well, right? Makes sense, right? So if I rewrite the logic here, if I rewrite the logic here, instead of this one way of writing, instead of this, what I would do is, for integer I equals to 2, I less than number I plus plus. So in between, if any number, that is number mod I equals to 0, then we can say factor equals to 1. Okay, so we are not initially incrementing the factor, we just gave factor equals to 1. The reason behind that is, if you could see this logic clearly, what I have written is, it should start from 2, which means I'm neglecting 1. One factor has been reduced, and now equals to, I'm removing equals to as well, which means 2 factors has been removed. If in between, if any number which gives remainder 0, which means it got more than 2 factors, right? 1 and itself, forget about 1 and itself, it will get one more factor added. Obviously it is not a prime number, right? So in that case, I don't want to iterate after it finds, like, if it has any number, then obviously I need to break it out, which means I need to come out of this loop, right? So in this case, if factor equals to 0, which means after coming out of this for loop, if the factor is still 0, means it doesn't have any other factors except 1 and itself. If it is factor equals to 1, means obviously it got another factor which is not a prime number. Okay, so in that case, what we're gonna do, I will change this number from 21. Obviously it has to return as, it's not a prime number, because 1 is a factor, 3 is a factor, 7 is a factor, and then 21 is a factor, which got 4 factors. It's not a prime number. Some cases they will ask you to write a program to find factors of a number, right? In that case, what we cannot do is, in this case, I will remove, sometimes they will ask you to write a logic to find what are the factors. It's not about printing but to check a number is prime number or not. Sometimes they will ask you to write, they'll get they'll make you confused to find how good you are at writing the logic, right? In that case, they will go ahead and ask you to write a logic to know how many factors that it has, or maybe I wanted to print the factors of a number, right? So in that case, what we're gonna do is, we are not worried about printing this number. Instead, what we're gonna do is, obviously, whichever number, okay, let me put this way and copy this, right? So whichever number it is divisible and gives remainder 0, that number is a factor, right? So in that case, what we're gonna do is, we need to print, instead of this, we're gonna print factor, that is number I is a factor for, that is for this number. Okay, so if I print this, if I run this code, you could see 1 is a factor, 3 is a factor, 7 is a factor, and 21 is a factor. Okay, so this is how we need to think in this way to write the logic for the same, right? Thank you very much for watching, and happy learning. So in the next video, we're gonna talk about how to print prime numbers from 1 to 100. This may be another interview question which would be asked when you get into mid-level experience, like 2 to 6 years of experience. They may ask you this question: how to print prime numbers. If you are getting into testing side, especially into automation side, they will ask you this question to write a prime number, to print a prime number from 1 to 100. Okay, so now we got how to find a number is a prime number or not, but we need to write a logic to print prime numbers from 1 to 100. And also there may be a question which would be asked, can you print a prime number, alternative prime number from 1 to 100? Okay, so I'm going to make a video for the same. Leave your comments, whichever program that is making you to get confused, I'll make a video for the same. Happy learning. Thank you very much for watching. Happy learning.